All right, so we're gonna look at this little breakdown of the tiles. So the big square tile represents x squared. So I know that it says it at the top, but I want you guys to make sure that you really label these correctly. So the big gigantic square, we're gonna let that equal x to the second power. And then the little skinny long tiles, we're going to let those represent x. And then the little very small tiles, like the little squares, the boxes, that's going to just represent 1. So what we're going to do, if they're colored in, so if we have a big one and it's shaded, this one is going to be a negative x to the second power. So think of it as like red. And then if we have one that's long and skinny, but it's shaded, we'll say that one's negative x. And then if we have a very small one and that one's shaded, we'll say that's negative 1. So number 1 is already drawn for us. So number 1, it says 3x to the second power. So I'm reading the polynomial over here, 3x to the second power. So that's why they drew 3 positive x squared boxes. And then I have negative 2x. So that's why they have 2 of these shaded in ones. That's negative 2x. And then positive 4. So that's why they have 4 of these little tiles. Second polynomial says negative 1x to the second power. So that's why they have one of these and it's shaded in because that's the negative 1x to the second power. And then they have minus x, so they have another one that's shaded in. And then they have minus 2, so they have 2 of the little shaded in ones. Okay, so all the ones that are shaded in, those are negatives. And now what we're going to do, we're just going to eliminate every negative with a positive. So I'm going to eliminate these 2. Because 1 positive and 1 negative eliminates. They equal 0. Now, how many positive x squareds do I have left? I have 2 positive x squareds left. Okay? Now, I don't have anything to cancel out here because I don't have any positives. So that's how many negative x's? 3 negative x's. And then I can cross these out because that's 1 positive and 1 negative. I can cross those out because that's 1 positive and 1 negative. So how many positive ones do I have? So plus 2. So our final answer, we're going to write 2x to the second power minus 3x plus 2. So the first one says 4x. So that's a positive. So I'm going to draw 4 of the positive x's. And then I have minus 3. So now I'm going to draw 3 of the little ones and I'm going to color them in. And then I'm going to add that to negative x. So now I have an x, but it's shaded in because it's negative. And then minus 2. We have our negative x, but we also need 2 more of the little ones that are shaded in because we have negative 2. So now we're going to cancel anything out that we can cancel out. So here's a positive and here's a negative that will cancel each other out. So how many positive x's do I have left over? I have 3 positive x's left over. And then I don't have any positive ones to cancel out. So I have 1, 2, 3, 4, 5, and they're negatives. So I have negative 5 little tiles left over. So my final answer, the polynomial 3x minus 5. So we're going to draw the picture, draw the model, then we're going to cancel out our positive and negatives, and then we'll count how many we have left over. So now I have 5x to the second power. So I'm going to take that big block, I have 5 of them, 5 positive x squareds, plus 6, and those are the little positive tiles. So here's my plus 6. And then I'm adding that to 2x to the second power. So I have 2 more big blocks of x to the second power. And then minus 2. So I have 2 little negative tiles. So do I have any negative big x squared tiles to cancel out? No, so I just count how many positives I have. I have 1, 2, 3, 4, 5, 6, 7 positive x squareds. I can cancel out 2 of my little x tiles with the 2 negative x tiles. And now I have 1, 2, 3, 4 positive x tiles left. So plus 4. So my expression, the final polynomial, 7x to the second power plus 4. So number 4, we're going to draw the first polynomial. So it says negative 4x to the second power. So I'm going to have 4 of the big x squared tiles, but they're going to be shaded in because they're negative. And then I have minus 3x. So I'm going to have 3 of the long skinny tiles, but since they're negative, I'm going to shade them in. And then I have minus 6. So I'm going to have 6 of the little small tiles. And since they're negative, I'm going to shade them in also. So all of my terms in my first polynomial are negative. So all of the tiles are shaded in. And then the second polynomial says 2x to the second power. So I'm going to have 2 of the big x to the second power tiles, but they're not going to be shaded in because they're positive. Minus x. So I'm going to have another long shaded in x tile. And then plus 4. So I'm going to have 4 little bitty tiles, but they're not shaded in because they're positive. Now, any of the ones that I can cancel out, we can cancel a positive with a negative. A positive with a negative. Bless you. So how many big x squared tiles do I have? 2 of them, and they're shaded in, so they're negative. So negative 2x to the second power. I don't have any positive x's to cancel out, so that means I have negative 4x tiles. I have 4 of them. They're all negative. They're all colored in. And these 4 negatives will cancel out with these 4 positives. So how many? Yeah, 2 little negatives are left over. So my final expression is negative 2x to the second power minus 4x minus 2.